Hi friend, this is the first lecture under category of this random variable and that random process, that probability already I have discussed in my introductory class. Now today's topic is random variables and the probability. So in this particular lecture, what are the things we will study? That is number one, the probability of the random variables. So here the things are associated, what is the term probability and what is the term of random variables. I will come one by one. Again, the second part is the relation between sample space and events. So what is sample space, what is space, what is sample space, and what is the events, that we will study. And the next part is the probability mass function, that is PMF and PDF, that is probability distribution function. And the next one is PDF joint PDF and the marginal density function. So what is a PDF, the density function, again what is a joint PDF, and what is a marginal density function, that we will study. Again, the next part is the mean variance and the covariance. What is the variance, what is the statistical mean, what is the statistical average, what is called the mean variance, what is the covariance, all those things we will read one by one in this particular lecture scope. Now here our topic for today is number one, key role under randomness. So here if we consider the class of signals, so what is the signals? Signals means one waveform, but any waveform cannot be a signal. Actually, what is the difference between signal and noise? That every waveform is considered to be a noise, but if a noise represent itself to something be a more meaningful, then it is called the signal. So signal may be periodic, signal may be aperiodic, signal may should have some rules, some norms, otherwise signal may not follow some rules or some norms. But still, whatever you are considering on signal, the signal must carry some meaning, signal must have some sign. But if you don't have any sign or any meaning in a particular given or incoming waveform, then it is considered as a noise. So whatever the data, whatever the knowledge, whatever the information that we want to extract from a given signals, it basically resides in a very small particular zone, and this particular zone is called the total full of information. The other part, which is far away of the discussion, which is far away of our consideration, is basically called the noise. So if you are not extracting anything from that given waveform, from that incoming waveform, so obviously that entire thing will be treated as a noise. But if something meaningful is there in a particular segment of that given noise or that particular segment of that entire incoming signal, so it must called as signals, otherwise it can be considered as a noise. So signals may be classified between two category. One is called the deterministic signal, another is called the non-deterministic or the random signal. So what is a deterministic signal? Deterministic signal should have few categories, they are very important to point out. Number one is the deterministic signal in which you can predict the next step. It means obviously it is a mathematical function. Say suppose example a sin omega t, if represented as ft, so obviously ft should have some particular value of that t equals to 5 second, t equals to 10 second, where that omega is known to us. So this type of signal is called the deterministic signal. In my particular slide also I have given that deterministic signal can be represented in that form of this a cos 2 pi fct plus phi. Here what is fct? That fct is a frequency, that fc part, that phi is a phase part, and a is the amplitude part. So these things are called the parameter. A, frequency, and the phase. This particular part is called the parameter of a signal. So what is the deterministic signal? In a particular waveform, in a particular mathematical expression of a signal, if these parameters, it means frequency, phase or amplitude, is known to us, or we can predict the next step if the first step is given or the mathematical function is given, so this particular signal is called the deterministic signal. The term deterministic means which can be determined, but another class is there which is called the non-deterministic or the random signal. So what is a non-deterministic signal? So obviously it is a signal, it should carry some meaning, it should carry some sign indeed, but non-deterministic in the sense, it means it cannot be expressed in that form of mathematical expression. So one non-deterministic or the random signal is this which cannot be expressed in terms of mathematical signals, or general mathematical expression cannot be useful for this, but it should have some value or it should have some meaning. So that non-deterministic signals are basically called the random signals. It means in which when you are standing in the present input, you cannot expect whatever the future output coming. So here we can jot down few meaning, like here we can see number one, this one, that future values cannot predict precisely in advance. Okay, so it is a very important part for categorizing that non-deterministic or the random signal. So the second point is very important, that it cannot present mathematically. So whatever the random signal, it cannot present mathematically and cannot predict precisely in advance. Now what are the examples for this? Say in our air we are getting different type of signals like speech signals, video, computer data, sensor data, etc. These all are categorized in that class of random variables. Now interference is a very wide factor in the term of EM waves. So whenever you are receiving that signals in a receiver, so obviously there are signals, there are noises, and the noise, except there are some interference term. So what is the interference actually? We know that when two signals are coming from a same source, it should have some phase delay inside, so it could interfere itself. It's a phenomena of physics, and the signal output will be distorted, create some new signal. So interference, it means when a signal transmitting from a particular source, on the way it may interact, it may collide with some trees, some buildings, some other major parts, and by the reflection there will be one difference in phase. So when that in phase signal and the deferred phase signal are meet each and other, so the interference started. That interference is also affecting that main wave. So interference is a big issue to be cleaned out, this one. And the noise signal, here you can see that noise signal, here you can see the noise signal I have just given. That noise signal also creates some big interference, so that you can see here that noise signal can interfere itself or create some big issue inside. So the noise signal can interfere or distort in receiver in additive nature of that receiver. So in that receiver, the noise signals, the interference, that other signals are just mixed up. So due to that mixing, it cannot be separated out. So it is a big issue how to separate that noise signal, the interference data and other thing, and how to extract the speech or video signals or the computer data from a given input. Now if it is deterministic in nature, so it can be easily predicted, some mathematical functions, some circuit can be easily built to extract the original one. But if that signal is not deterministic in nature, it means it is non-deterministic in nature if found, or the random if it is found, so still these facts are very important to segregate, that interference, that noise signals, this distortion part should be eliminated in that nature of the receiver. So non-deterministic signal described in terms of its statistical property or the average. So we need a detailed understanding of the probability theory, and here the concept of the random variables and the random process are very much important to discuss. Second thing, the information and the noise in the communication system. So it is mixed up, so we have to separate it out and eliminate. Number 3, to measure and analysis we need some mathematical tool which will have that statistical property. So that mathematical tool which will not support the statistical propagation and the statistical mathematical analysis, that cannot be useful for understanding this type of random signals. So to analyze the random signal we need some mathematical tool which will have the statistical property. Now point number 4, which is used to understand that detection technology. Okay, now here the slide number 2. Here the points are what? That probability theory based on statistical experiment. Fine. So what is a statistical experiment and how probability theory is based? So number 1, outcome of the random experiment. It means that a generation of random events and that signals. So what is point number 2? That outcome of the random events is based upon the expectation, that is based upon the function of the random variables. So what is a random event and what is a random experiment? So one experiment can be anything. Suppose we are tossing a coin or tossing a fair die, or we are just doing some probabilistic calculation that whether the rain may be there today or not, whether it is a sunny morning today or not. Like this, it is all the type of probability calculation. So in this type of case we need some experiment, that before prediction of a particular thing or a particular element or a particular data we should have some previous knowledge on this. So that prediction entirely depend upon the previous knowledge. Now here the outcome of an experiment, if it is taken as a random experiment and that event in which that experiment takes place, that we will call the random events. If it is so that experiment must govern with some previous rules. So if one experiment is done under a set of rules, so that particular experiment cannot be a normal experiment. It is a fact of random experiment. So one random experiment should have some outcome and that outcome of that random experiment will generate one term that is called the random events. So outcome of the random events is based upon the expectation based facility, that is upon the function of the random variables. Now the random variables are of different nature. So the first one is a Gaussian random variables, is very much important in that communication engineering. Except that Gaussian random variables, there are different more random variables, that is Rayleigh distributions, that is Poisson distributions. So different distributions are there. One of the distribution is the Gaussian distribution. So the Gaussian distribution of the random variables plays a very important role in analysis of random variable signals, in especially communication engineering. Why? Because the noise which will be taken care of is basically taken in the form of Gaussian distribution. So Gaussian noise distribution, basically we are calling it as AWGN, that is additives. A, W means white, G means Gaussian, N for noise. So additive white Gaussian noise, they are playing a very important role in communication engineering for detection of some random variable signals. So the fourth point obviously coming as a white noise. Here you can see that white noise like this plays a very important role of additive white Gaussian noise in communication system. And the fifth one is a narrowband noise, so can be viewed as in phase and quadrature components. that narrowband noise. So what is the example? That is narrowband communication system, which we will discuss further in our lectures. Now the term has come as a probability theory. So here the probability theory is governed by that experiment, which is a set of rules that governs a particular operation to perform once it is completed, called as trial. So one experiment and a trial. What is the difference? That experiment may not have one set of rules that governs the operation, but if it is a trial, a special type of experiment, it must govern with some specific rule, and the result of the trial or the outcome combined in an event. So these all called the random process or the random experiment, and experiment that is head or tail, whether that event A is only head, so the relative frequency of outcome is Na by n, as I am talking to you, which is already told to you in that particular class, in the introductory class, where I have a lot of discussion with you that what is the experiment, what is head and tail experiment. In this case, suppose you have a coin. If you are tossing the coin, so either the outcome is head or the outcome is tail. So total number of fact that can come, that is either head or tail, so total n is 2. So probability of that head is what is the relative frequency, that the total number is n, that head will come for only one time. So here, so when that particular form, you can see that is relative frequency Na by n, it must lie between that range of 0 to 1. When n is very small, so Na just likely to be a integer, but if n is going to infinity, it means if n is very much bigger, so Na by n, that particular ratio, that relative frequency is called the probability of A. But if n is very small, so what happened? Something by 0 is undefined, so that Na by n is uncertain. So the probability of a particular event, probability of a particular outcome, if you are calculating, so in this case that n has to be much bigger, and then only it just arrive to that PA. Now what is the axioms of the probability? That each possible outcome is associated with a sample point S, and all the sample point is created a sample space S and called the sample space. So what is the difference between sample point and sample S? So each and every experiment will create that sample point. If you are tossing once head and tail, if you are tossing twice head and tail, if you are tossing thrice head and tail, or that thrice head and tail, so their all possible result is located on a particular sample point, that is S. Now all these sample point, if you are accumulating all this sample point as S1, S2, S3, S4 in this way, so all the sample points are commonly summed as a sample point, sample space S. Here the sample point is small s, but the sample space is capital S. Okay, so the impossible events is called the null set, that is phi. So say for example that throwing a dice, if you are doing this, so and dice have 6 faces, 1 2 3 4 5 6, so 6 sample points are there. Okay, so now suppose we are tossing the die, the head this is not the head, either 1 or 2 or 3 or 4 or 5 and 6, in this way whatever come, it may be 5, it may be 4, it may be 3, anything else, but total possible outcome is 6. So what is the probability of getting 1? That is 1 by 6. What is the possibility of getting 2? That is 2 by 6. In this way the different point should have a different samples point. So here the 6 shows, that is sample point 6, the probability is 1 by 6. The event statement here 2 shows, you are tossing a die, the 2 will come, the probability is 1 by 6, because 6 probability one number is coming, so the probability is 1 by 6. In this way, one even number of data set may be having sample point 2, 4, 6. So what is the probability? That is 1 by 6 plus 1 by 6 plus 1 by 6. So if you are considering that a particular data set where the only even number comes, the probability is 1 by 6 plus 1 by 6 plus 1 by 6. So it is 3 by 6. So it is half. So if the question arises that what is the probability that 1 come, it is 1 by 6. What is the probability of 4 come? That is 1 by 6. What is the probability of 3 come? That is also 1 by 6. But what is the probability that only even come? That is 2, 4 and 6. So for 2 it is 1 by 6, for 4 it is 1 by 6, for 6 it is 1 by 6. So overall the number is half. So the probabilities are cumulative. So you can add the different probability to get that different sample point. Here the probability PS equals to 1 at final, where the limit n tends to infinity, na by n equals to 1. Fine. So here if you are considering both probability PA and PB, it can be written as A union B. So already I told you that if you are having that NA union NB or N A union B or N A plus B, it can be written as NA by N plus NB by N if those are same. So just adding up, we are getting that final probability. Relation between the sample point, event and the probability. Here I already told you that sample points are basically that value. Here that NA by N, this is a sample point. So this sample point is coming to that S1, that is event A. In the same way, event B, the sample probability is NB by N. Here for event Sn, the probability is N suffix N by N. So all these are creating some different value which is standing in that region of 1 to 0. So obviously these S1, S2, S3, S4 up to Sn, this I want to mean, these all are creating that sample space. Okay, and in that sample space there are the sample points. So it may happen that in a particular sample space there may be one sample point, or in a particular sample space there may be a lot of different sample points. So mutual exclusive events, some values can be given that PA and PB, they are the mutually exclusive. So if one happen, the another will also happen. This is called the mutually exclusive event. So in this case some value can be given. So it is PA equals to PB, that is equals to 2. Now what is the random variables? Here the mathematical analysis outcome of the random experiment are not conventionally represented. Now the random variables is a rule in which you can assign some value to that ratio. It means that ratio, what I want to mean, if you are having a particular value to this particular, suppose this ratio, you are having a particular value. So this particular random experiment which will create some sample point, if it is having a particular value, so this particular value is called that random number associated to this, and which variable is having such particular value is called that random variable. Okay, so here the random variables is a rule which assign a real number to each possible outcome, or a function whose domain is a sample space S, capital S, whose range is a set of real number is called the random variables of an experiment. Okay, so here I am just making it quite easier. Suppose S1 is a particular sample space, it is event A, and event A, that particular S1 having one sample point, that is x of S1, that is Na by N. That Na by N, which is capital X of S1, we are just putting it as small x1. So this particular small x1, this is the value. This value is associated with this variable. So it is a random variables, and this is a random number which is associated to this random function, that is x of S1. But that value of that function always ranging in that range of 0 to 1. So this is called the probability set. So one event may have more than one random variables or one event may have only one random variables. This depend upon that case. Here the conclusion of the lecture, I should say that the S1, S4, S6, that is event B, where we are considering only that event number. So these things, so if you are joining them together, so it will giving one particular number which is half. Already I have discussed 1 by 6 plus 1 by 6 plus 1 by 6. So that is also ranging in this particular region. So in this way, one may have more than one random variables, or only one random variables can be there in a one sample space. So that is all for this today's lecture. We are concluding. Wait for my next lecture in the next part. Thank you very much.